DevOps, Docker, and security. This is a little bit of meta. So if you want to geek out on Docker during an open space or whatever, we can do that. As some of you might know, you almost need a PhD these days to explain all the componentry of Docker. So a lot of pieces, a lot of moving parts. But yeah, I mean, I'm just going to kind of breeze through the Docker part. This is a general, like you never know what the audience knows about DevOps or Docker, or in this case, I do want to include some of the interesting components about how you can combine these three to be more secure. So about me, all my presentations over the last 6 years are on my GitHub project, which is Botchagaloop, which is a horribly long, stupid name. But if you can get there, then you know my Twitter account, you know my Gmail account, and you know my GitHub account. And I have all my presentations, including this one, will be up there. And I've done quite a few over the years, so it's worth going there. I'm considered one of the founding members of this DevOps thing. I was the only American at the first DevOps days in Ghent. I came back and kind of evangelized the concept in the US, created the first US-based DevOps conference, and kind of been part of that ecosystem for quite a long time. About 6 years ago, I befriended this gentleman, Gene Kim. He wrote a book called The Phoenix Project. He was about 6 years into that project. We had a collaboration. The Phoenix Project is a novel. How many people read The Phoenix Project? Yeah, good amount. It's an interesting, it's a novel about IT and failure and theory of constraints and bottlenecks. It's a great story. But we knew that we needed to, the problem was it is a novel. So you were going to read it and say, okay, how do I fix this? And so we started on a journey 5 years ago of creating this book that we thought would be the prescriptive guide. And we talked about moving fast and being lean, and it took us 5 years. So do as I say, not as we do. I want to show you one other thing later. I wanted to give you a perspective of who I am, and not so much, I mean, I guess I am bragging, but I've created a tremendous amount of resources in the catastrophe in my wake. Even my DevOps Cafe podcast has just about everybody who's been extremely important in our industry. So that alone, just listening to Jez or Gene, or, I mean, name your icon in DevOps, we've interviewed them, and there's a podcast out there. In fact, Sidney Decker, I mean, just about everybody you can think of. So I'm also a founder of an Enterprise Summit. I was early in at Chef. I've done a lot of startups. The startup gods were really miserable for me for about 25 years. The last 5 years, they've been very nice to me. I sold the company to Dell about 5 years ago, and as it was earlier, I sold the company to Docker a little over 2 years ago. I wanted to point this out. Took a whole year to write this. The original Linux Foundation came to me and say, could you write a course based on the DevOps handbook? And I naively said yes, and then I realized there was so much more that we didn't cover in the handbook. So it literally took me a year. They're furious at me. It's free, and it covers everything. So, I mean, if you want to know about Melvin Conway, or you want to know about Peter Senge, and I mean, I can go off and off and off on all these like incredible people that have contributed to what today we call DevOps. 15 hours of video. In fact, shortly I would say that people ask me, if you take the course, if you take the straight 15-hour videos, a 15-hour course. If you watch all the videos I tell you to watch, it's probably about a 40 or 50-hour course. If you read all the books I tell you to read, it's basically a 4-year degree. So, it's your choice. Okay, so I'm a big shot. Hey, all right? Hey, DevOps, folks. So I'm in China last year, and I just have no clue why I do this periodically. And I don't know how people know Sensu. They're a bunch of young, nice men. But they decided to take this picture that somebody captured of me. So here's the thing, like, you ain't shit until you've been memed, right? So I've been memed. And then now they look for pictures of me where I'm doing something wacky. So I gotta be really careful. Like, I gotta keep my arms down, because then they start it all over again with a new one. So anyway, all right. What if I told you could be 2,000 times faster? Okay. What if I told you could be 1,000 times more reliable? Okay. What if I could tell you could do both? All right. By the end of this presentation, I'm going to show you an example of a large insurance company that fit a certain set of patterns where these are the numbers that are the results. And so when I say that, just keep it simple. There is overlap between these things, but I would say that DevOps can make you faster. Docker, and containers, Docker is my favorite brand, can make you more effective. And then we can learn a little bit from how Toyota built cars from like 1970 to 2010, from something called supply chain, that can make you more reliable. Now I'll tell you, put it all together, Docker make more reliable, there's even. But if we look at these three patterns, and again, I've got a case study of a company that literally took these three patterns and did some, and I'll show you some phenomenal numbers. So DevOps is, for the people who are being initiated, if there are any, my friend Damon Edwards, my co-host of the DevOps Cafe podcast, basically, I think this is still today the best caricature of, when you want to explain DevOps to somebody, it's this, we used to say it's about the aha to the ka-ching. How do you get from some idea to actually kind of making money or having a customer that is happy? And so what are the things that happened there? Well, the first thing that started was this metaphoric wall that was in front of Dev and Ops. And today it's really a metaphor for any wall where you can't move because there's this siloed and non-collaboration. So DevOps kind of fundamentally is trying to crash that wall between Dev and Ops, but certainly now any group. But it's more than that. It's about shortening the lead time of what it takes for you to deliver things. Like if you can deliver things fast, you're better than your competitor. If you've got a competitor and it takes them 4 revs and only you 2 revs to create the same feature, like you win. And then finally, we want to kill bad culture, break a wall. We want to move faster, like how can we do that? And then we want to be really good at feedback loops, telemetry. So we want to basically amplify feedback loops. We want to move fast, amplify feedbacks. So this picture tells it all. And so early on in this DevOps movement thing, Damon and I created this thing called CAMS. It's been reasonably sticky as a taxonomy, although I will not call it a taxonomy, and we never intended. It was actually a podcast at the first US-based DevOps. So the first DevOps in Kent had like 35 people. 6 months later, we had 300 people in Mountain View. And we couldn't understand what just happened. It was like a nuclear explosion. And we got on this podcast and we were like, what happened? What was it? And we like accidentally came up with this acronym of, like culture. It seems like we're going to have to put culture first. And then we can do automation. And certainly we should have a measurement concept. And by the way, it's actually what I learned years later is it's a cybernetic feedback loop. Hopefully that didn't scare the shit out of you. But the fact that it really is it's a cycle. The way the sharing becomes part of the culture, and it's some people might call it a virtuous cycle. And then Gene, while he was coming out the Phoenix project and we were doing the DevOps handbook, he made a really simple codification of DevOps. He said DevOps can be described by this concept of the 3 ways. The first way is the left to right, how you do flow. Remember my early picture? The second way is about feedback loops and amplifying feedback loops. How do you catch things downstream and move them earlier in the process? And then the third way is continuous improvement, right? And so, I realized really, for the most part, we were saying the same thing. And I was actually kind of involved in the 3 ways, but Gene is the person who really put the stake in the ground. And so the DevOps handbook, I'm one of 4 authors. I kind of joke I'm the dumb one on the list, because the other 3 are just amazing people. So if I tell you that this is an amazing book, I will tell you in all honesty that it's amazing because at least 75% of the contribution are from amazing people. I'm not really an idiot, so maybe give me 15% more and you're up to 90, right? The point is, I can tell you, I was telling somebody earlier when we were walking over, it's like, when we were doing the final edits, it took so long, we had so many rewrites, and I was literally, when I was reading the final edit, I was reading as if I wasn't the author. And I was like, my God, this is a damn good book. It's got 48 case studies in it. You will see your company in one of these case studies, insurance, bank. And we model it after, a lot about continuous delivery, which really is the elephant in the room in this thing we do. But certainly a lot of the principles that we think about from a culture. And again, watch any DevOps culture presentation. There's completely expanded, very good explanations of all these things. But here's the thing I did want to tell you. Is that when I started in this DevOps movement, you started seeing these, for me, I was really frustrated. So if we say that Patrick DeBar in 2009 ran the first DevOps day, there was this euphoria around 35 people. Lindsay Homewood actually was one of the person that was there. He came back. Matt Jones started the kind of Australia thing, if you will. There were a bunch of people from England. I went back to US. And you knew it was right. You knew. I mean, I joke I was about to start just selling shoes for a living. I was tired of IT. I'm not really helping anybody. And all of a sudden, these young kids are just flinging stuff around with Ruby and actually I was working with Chef quite closely at the point, so I kind of was a little happy. But you had this kind of empirical knowledge over the years that what we were doing was making people faster, but we were also getting better at how we did it. But then in 2015, a couple of years, it started a few years before, Gene started running this survey. It's called Dell Surveys. Puppet Lab sponsors it. We surveyed over 30,000 people over the 6 years. But in 2015, we brought in this woman, Nicole Forsgren. Why did I forget her name? And she was a PhD statistician. I mean, she knew stats and data, and she knew something called psychometrics, which is actually the right way to get valid statistical data out of survey. And I won't go into detail, but basically her questionnaires, actually with Jez Humble, basically allowed you to self-identify whether you were called a pathological organization or a generative organization. It was actually a bureaucratic in the middle, but I'll talk about the extremes. And so you self-identified. And so pathological were you got fired for failure, there was no sense of inquiry, there was blame and all this stuff. And generative was a failure was embraced or created inquiry, like all these things. Interleaving with those questions, she'd ask how many times do you deploy a day? What's your resolution? What was interesting, we finally had real statistically sound data that told us that the people that were generative in culture basically we're 200 times faster at lead time than the pathological. Hey, good culture creates fast, speed. But what the blow-away moment for me was now I had data to say, by the way, they were also 168 times better than the pathological cultures at restoring service. So guess, so faster, higher quality. And actually in 16, it was 2,555, right? Crazy. But here's the thing, right? For those of you who are a little bit older or maybe very old like me, right, we've had this golden triangle concept, pick two, and DevOps was really born out of this fast and be risky, or slow and be safe, right? And the data, I mean, again, people who have been practicing this, and some of you in the room, we knew this wasn't true. We knew you could go fast and be more resilient, but now we had statistically sound data by a PhD statistician who is, a qualified psychometric that knew how to write. In fact, Jez Hummelhurst submitted a paper to academia to be approved. Right? So this is rigorous. This isn't just somebody doing a bunch of stats. This has been submitted scientifically as a science paper. And so what does this mean, right? You've probably seen this picture somewhere along the way, right? Which is this idea of how do you build resiliency through continuous delivery. The thing you might not hear very often is it's built around amplification of feedback loops. Somebody submits something, you've automated the build and submission process, and it hits the first gate, gets kicked back, you fix it, it hops one more, hits the next gate, pops back. And so you're constantly amplifying feedback, which actually makes you more resilient, and because it's automated, you literally get faster. You know exactly what went wrong. In fact, when it gets wrong down here, you try to put it back here to test. So you get faster and faster at resolving failure. And so I didn't keep a timer, so I may get myself in trouble here. But so there's this story that I love. So what I've learned also over the years is a lot of what we do comes from actually Lean and Toyota Production Systems. And there's a story about a Toyota plant in the U.S. that created 2,200 cars a day. And some analysts went in there and they asked, how do you do 2,200 cars a day? How many people have heard of the Andon cord? A lot, good. So in Toyota, they actually had a rope as the cars were going down the line. And anybody at any time could pull that rope and it stopped the line. And in fact, kind of another culture ism that made that company great, which was the first thing the floor manager said to that person is thank you before they even knew what happened. It was a psychologically safe environment, right? So you pull the cord. So the answer, now that you know what an Andon cord is, was, oh, yeah, it's easy. We pull 5,000 Andon cords a day, right? And that's this. But guess what? And this is 4 years ago. Google's over, it's the last time I searched, over 100 million test cases a day. That's that Toyota plant. 100 million tests a day? That's how you get great. Now, you can hate Google, love Google, but you can't argue about how they deliver service and infrastructure. You know, and then, you know, there's the, you know, for those who've been seeing DevOps presentations for years, I'm like tired of telling this story, but it's a good story. Amazon at one point, and the numbers are even way higher now, production deploys every 11.6 seconds. At one point, 1,000 kind of max deploys in one single hour. These are production deploys, folks. And now, as I get to say, and so shamelessly stolen from Pete Cheslock, so I give attribution. His was Devops and Security. But there are some enterprise people in this room who are saying, this guy is so full of shit with all this shit, because I ain't Google and I ain't Amazon. Well, we've been running a DevOps Enterprise Summit for 4 years. And we have companies come into this where they're telling us these stories of how they're doing exactly the same stuff as Google's doing. And they're getting 98% reduction in MTTR while going faster. Nordstrom, 20% shorter lead times. Target has a 15,000 square foot DevOps dojo. Google it, it's brilliant. People beg now to come into it to get immersed in things like Lean and Kanban. USA, ING, CSG, I've got some great stories about CSG if I have time of how they've built such a resiliency in their pipeline. In fact, quickly I'll say, they've actually been able to convert a mainframe application, 135,000 mainframe assembler, to a Java application. And the only reason that they had the courage to do that is that over 5 years they built a pipeline with a bunch of principles that look like this. And to them it was no different than building a Python application. Imagine that. You convert a mainframe application with the same sense of security as what you do with Python. Like, it's a non-issue because you have such a belief in the system that you've built. All right, so Docker. Hey, man. You know, all right, lots of shit. You know, we've had more times, kind of fun. One day I wanted to sit down and think about the history of all this crap, and, you know, I tried to get it all right, you know, and I blued the things that, like, led ultimately to Docker, which, .cloud. So, and then, you know, most of you should know this. If you don't, like, please leave the room now. No, only kidding. Type 1, type 2. You know, I think Brian Cantrell actually calls it OS level virtualization. There's actually Wikipedia, you know, so it's a form of kind of OS, different from type 1, type 2. But the real story is, for those who don't know Docker, who are very rare that you find people these days, but I have to repeat it really quick, is a couple of things. It runs kind of on a process, so it has, you know, an order of magnitude faster. Like, if you start up a Docker container, because it is really kind of a Linux process, and now it's a Windows process as well, you know, it'll probably instantiate in about 400, 500 milliseconds as opposed to a VM with a couple of minutes. It shares the host operating system, the kernel features, so that you're talking about, again, mileage varies, but maybe, you know, 100, 200 meg versus gig, and it adds up. It adds up in so many ways of speed and variance and all these things. You know, you provision in milliseconds. It's basically bare metal speed. You know, it really, it's funny, when I started with Docker, it was like greenfield, don't touch any legacy. But we find now there's actually this concept of a lift and shift, or you can take, like, the oldest, ugliest apps, and they actually been container. This guy, there was an insurance company guy told me the other day, they took a fleet of 100 XP servers with an old application that nobody dared to touch, and they put it on Alpine Linux running .NET. And the developers didn't change any code. And they didn't care. They were like, okay, as long as it don't break. So imagine that, taking a fleet of XP systems and now running on Alpine Linux containers that are running the open source .NET libraries, and the developers didn't have to do anything different. I wouldn't recommend do that for everything. It's an extreme case. If you look at, Docker, it's based on LXC from a Linux perspective. So, okay, Linux has isolation, it has lightweight. I think, the bigger thing that, Solomon Hykes, who kind of, invented this thing called Docker, didn't invent containers, it was simplicity. It was like the first time you used Docker, you're like, oh my God. And I tell you, if you were somebody who tried to do Linux containers on Amazon before Docker, it wasn't fun. The workflow, it's actually now people will tell you, and I've got another presentation I do, I say, by the way, your containers are more secure than the VMs. By the way, your containers now can be more secure than VMs. If you want to argue that or have a debate about that later, I'd love to have it. The workflow is pretty powerful. Solomon has this maniacal sense of it should always be easy. So, he's forced the developers to make sure that the same interface, even when you're running your kind of cluster and orchestration, is exactly the same on your laptop as it is going to be in production. So we got Docker from Mac, and you basically run Swarm and everything. I love Vagrant. I use Vagrant, Vagrant was my go-to tool before we had Docker for Mac. Because Docker for Mac, I can build a cluster, an orchestration cluster with everything I need, how it's going to scale on my laptop, natively on the OS, and it's going to be exactly the same through the CI and production. It's not Vagrant here, and it's an AMI here, or it's, I've isolated. Let's skip that. All right, so the last piece is I told you that, if you do DevOps and you do Docker, some nice things could happen. And so I'm sitting in DevOps Days, Austin, about 2 or 3 years ago, and I'm giving this immutable delivery presentation. And I'll talk a little about that in a minute, about how you can developers can create immutable infrastructure in a container so that when it leaves their desktop, it is binarily immutable. And I can go on about variation and how that, and no knock against Chef or Puppet. I'm a stockholder in Chef. But if you have to build infrastructure as code at every layer, that's a layer of variation at scale. There is a butterfly effect, no argument. So if I knew that my whole infrastructure was immutable every way through the process, when it left my desktop, and it was tested with everybody else's, if in a microservice world, kind of immutable services at the right releases. And then it went into the CI, and it was the same pull down. So now you think about your kind of artifactory or artifact thing being anywhere in the pipeline. Different from when we get here, then we go push it. It's immutable from the beginning. I call it immutable delivery. I have coined that term. I don't ever get any money for it, but immutable delivery to me, you've heard immutable infrastructure, right? But immutable infrastructure starts at the artifact position. In this model, you actually started a developer, and developers love it. Because when you get paged in the middle of the night, by the way, DevOps kind of says developers are web pagers, they have a really good sense of whether it's an infrastructure or it's their problem. The boundary is a lot clearer. All right, but the problem was, I'm sitting there going, oh man, that one person is going to ask me that one question when I tell them that I can go faster is, okay, John, what happens when you have 10 million of these out there? Oh God, please, nobody ask me that question. Oh, got away with another one, got away with another one. So I'm speaking in Austin about 2 or 3 years ago. And Josh Corman, who worked at Sonatype now, is a white hat guy, and I give a whole presentation about the awesomeness of Josh Corman. Don't have the time. He gives a presentation right after me about how Toyota supply chain works really good in infrastructure. I'm like, holy shit, he just answered my question. So the next year we gave a peanut butter and chocolate a presentation called Immutable Awesomeness. And really what he was saying is something I hold very dear to my heart. It's just another variation of what something Dr. Deming has been saying for years. And I've done presentations called Deming to DevOps. They're out there. That's my icon, my Twitter handle. So what he was saying is, and here let's step back for a second. So there's a book called Toyota Supply Chain. And one of the things it points out is the difference between the Volt and the Prius for the first kind of launch of hybrid cars. And you can see numbers about sales. Toyota decimated them on sales, on cost, everything. But there's something, all right, I think we're going to give out books, and so this one is hard. Can somebody tell me something in those metrics that are totally counterintuitive? It's hard. I may even give you 2 books. I mean, there's no way I would have got it without Josh presenting it. So, all right. It's the suppliers. Like, wait a minute now. GM had, like, I think the percentages are wrong on the left. I clipped this slide from Josh's presentation, but like, if you look at GM, look at how many external suppliers they had. They had a lot of suppliers. But guess who did more in-house work? The guys who had more suppliers. That's not supposed to happen. What's interesting is how many people read the Google SRE book. All right, we'll get to that in a minute. So what Deming said and what Toyota did is said, use fewer and better suppliers. Now Deming said 1. Sorry, bud, can't do it. But you know what Google does? Google runs only 2 kernels at any given time. In fact, they got a team called the Death Squad. They don't kill people. I don't think it's a bad name. But what they do is, according to the book, if you're running an old kernel, and by the way, they do this for like Java framework, logging frameworks, and it's 2. They come in the office and say, hey, you know, you're on that kernel and we got to get you off. And they're like, yeah, just I'll do it this afternoon. And they're like, go, leave. No, we'll just wait here. That's our job. Like, no, you can leave now. No, I'll just, in fact, I work with Gene Kim. I do a lot of work with Gene Kim. He's got this style too. You see, Gene, I'll go ahead. You'll see, John, can you put together a couple of things? And I'll say, yeah, I'll just do it this afternoon. Because, you mind if we stay on the phone till you do it? Like, oh, Gene, you son of a bitch, right? But like, he guarantees that it gets done, right? So, I mean, that's the supply chain ideal. Because you know why GM, my theory, and you know other people theorize why they had more overhead and more in-house work? More suppliers cause more work. When they went into healthcare.gov, you know, that's a cliched story, so I don't even like telling except for this one point. When they did the discovery of health, you know, you guys heard about that, right? The debacle, it was, you know, they had 17 Java logging frameworks. So this is a year-old application that had 17 Java logging frameworks. You know, higher quality parts, well, that's that pipeline. The software model of what Toyota was doing is building that form of resilience. And the last piece was the one that like hit my soul, which is, okay, if I'm deploying millions of containers out there and all immutable, what if I just put the proper metadata in those immutable objects from the start? So now I'm treating like, you know, when GM needs to do a recall of bad brake pads, they know where they all are. So now I'm actually better because now I got like 10 million of them and I can do one CLI command and tell you exactly, depending on how much meta you want to put, what department, what part, what was the SHA commit, who committed it. Now I've got this like crate way better than I ever could have with VMs. You know, and so in the book they talk about the 4 Vs. You know, how much time do I have? Anybody? Like, I literally blew it on keeping track of time. But I mean, I got a total hour, but how much time I got left? Just depends whether I explain this. Well, it might take too much time to even explain. All right. Anyway, it's just that book will tell you that that you want to decrease variability. You want to economically think about your suppliers and vendors. It's an economics problem. You certainly want to increase velocity. You want to decrease variability. And again, that's why I would make this argument that containers, the immutable delivery model, is an exact. In fact, there's a great paper way back when called Order Matters. It's a Turing experiment of order matters. It basically says that if you don't build systems correctly or independently, in fact, at Chef, I used to use that paper against Puppet. Because Puppet used a dependency graph to build infrastructure, and Chef was order dependent. So I'd run around and pull out this paper from a scientist saying, by the way, if you do this at scale, like order will matter. And anybody who did Puppet and Chef back in the day who ran scale will shake their head and say, yeah, it definitely mattered. Now, today they're both equal. I mean, there's really no difference between the two products. But by Chef, because I still have stock in those guys. So variability is important. And then visibility, right? Like to me, that final secret sauce was, what if I could put meta in every container? And because it is immutable and it stays with the immutable service or the construct of the service throughout its life, boy, now I know everything about it. I mean, I can easily I can either mentally visualize where everything is, or I can throw it up on a beautiful screen and know all the componentry, even in the most complex millions and millions of infrastructure. When I got to Docker, I thought about that old paper. It's like, I'm going to use that old paper that I did now for Docker. And I wrote a white paper. It was called The 3 Ways of Docker. It's out there. And it really talks a little bit more detail. And it takes Gene's 3 ways of DevOps, and I talk about immutability and variability and the 4 VLs and all that good stuff. And if we want to put it in our terminology, it's something we'd learn faster. We want to limit our tools. I mean, there's no sense of having 8 or 10 different types of frameworks. So, well, I'm an enterprise. Well, tough. I mean, I'm sorry. Like, do you want to be like horribly slow when there's 0-day vulnerabilities? Velocity, right? We learn like small batch. Microservices obviously is a thing. They happen to mix really well with containers. And I would tell you this kind of model that I've been talking about, immutable delivery. Containers in general do it. Docker does have a better workflow than anybody else. All right, so you can argue whether you should use LXC or you should choose some other variant of a container. We can have that discussion all day long. But if you're going to argue with that there's a mature developer workflow, then Docker, let's have it. I'll take that one on. And it gets better every day. I mean, we make some bad mistakes. This is not being recorded, right? We do some stupid stuff. I'm out like over on the East Coast, and I'm like, oh, those young kids, what they do again, But, and I'm the old guy, like, oh, shit, John's going to complain again, So anyway, so I'm not saying we're saints, right? Like, all right. And invisibility, right? Like, and we've done a lot with the security stuff, automated, we got, trust in there, so now you can sign secure images. We've got built-in vulnerability scanning into the product. The big thing we did recently is we have secrets management built into the system. So when you start thinking about, like, again, this is kind of one place. I'll have one more slide where I'll be pitchy. I'm typically not a pitchy guy, and we have product pitching. But I will tell you that with Docker, you get orchestration, you get most of what you can do in any other orchestration, you get Docker, it's tightly coupled, so releases come out together, and you get all the things you need for security from either LDAP or signed signatures or vulnerability scanning and now secrets. And I think Vault and I think HashiCorp is awesome. But with Docker, you don't need Vagrant and Terraform here, and then this here with Vault here, and then Kubernetes with etcd, because even our we don't even use an external distributed key file system anymore. It's built in the system. So Engine itself has Swarm, and it uses a gossip mesh protocol, so you don't even have to have an external. So I'll tell you what, you want to have some fun, go read some of the people who run Zookeeper Scale and their operational experience with it. Like, at scale, those things actually become a whole nother animal. The distributed key file systems and etcd, any of those. I mean, it's a full-time job. No more pitching. This is a friend of mine, Ari Paneer, who early on in Docker, before we even kind of got enlightened, he was running a large, large for him, like his own little kind of ISP, and he was like, he wrote a good article. He said, how the hell am I going to operationalize this? I know I have to use containers. So he had this thing where I said, he just put in meta and he shipped everyone with a container.sh command, and he had like all this stuff in it, and his little command could basically, quickly tell him anything he needed to know about any container anywhere. He's the guy who wrote M Collective for Puppet, right? Like, so, like, he knew, like, how you have to think about containers before everybody else did. This is an interesting story, because I'd love to take some more time to talk about composition. I think this is a place where the industry is better to get our handle on, and that is the idea that we need a common abstraction so we can define all this stuff. And I'm okay with YAML, but like, because what becomes the real secret sauce between DevOps and Ops these days is where developers can actually compose human-readable structures that not only define how compute's going to run for each level of the service. Let's take a LAMP stack. It's got like some proxy level. It's got some web tear, and it's got a database, right? And obviously, there's more complicated variants of that. But I might want this type of storage on the proxy. I want block storage or whatever. I want a front-end network. with a mid-tier backend multi-interface. And then my second tier, I want maybe some type of thing like MongoDB or something like that, maybe MySQL, I don't know. And I want a front-end network interface, and I want a back-end interface network thing, but I do not want the front end to have, this is what VMware calls microsegmentation. So I want that, and I want to have, so here's what I want different type of computes, but I want all to be the same language. I want the service definitions to define it. I want multiple network interfaces on all the layers of services, and some might have different network interfaces. Some might be very secure and encrypted, some might, we don't give a shit. Some might be used VXLAN and overlay and SDN, some who gives a shit. I might want like, block storage, Ceph, and Cassandra. And so imagine I can build a composition that's human readable, where the developer doesn't even has to know it's like distributed to means Cassandra, and they don't give a shit. They just know distributed to is what they do for this type of work. But you get where I'm going. Gilt was talking about this kind of model like 3 or 4 years ago, how the developers could just build simple composition, and they really didn't have to think about anything else. That Google it, 2404, he explains it. This is the wording. I'm not going to read it out loud, but he literally talks about how, to me, is the birth, and I think we're better now. I was at Google Next, a pre-day at Google Next, and we had a long conversation. I let all the Google developers, like all the product owners, I got invited to a pre-day, right? And all the owners were talking about what's the right abstraction. I just sat back, and I knew if I said I'm the Docker guy, like I was going to get pummeled, right? I let them go on, and then I finally said, hey, I'm from Docker, so I think our compose is the right answer. I'm not saying compose is the answer. And then I explained that thing, this is a level where you can do converged infrastructure, human readable. And guess what? Well, I'll talk about something else in a minute. We've actually created something called Linux Kit. Well, now the operating system can be built with YAML, and it can be built just in time. So everything now can be in source control for not only a converged infrastructure, network started compute, atomic to the application or service, but now your operating system can be YAML-based just in time that fits along with that. Imagine, and it's an immutable operating system. So the final story I wanted to tell you, which is Aetna about 4 years ago, they publicly talked about, for years I couldn't say who they were, because, but at RSA they talked about it earlier this year. They had, back when they wanted to get started with this, DevOps, Docker, security, we're going to do this thing. They were tracking Sev 1 and Sev 2 security defects. And at the time they said they had 10 per 10,000 lines of code. Right? And in their words, they started out, they kind of started thinking about DevOps practices, continuous delivery. They didn't quite do this DevSecOps thing I'm going to talk about in a minute. And they got down to 4. They applied, Josh Corman went in there and told them, hey, guys, you got to do this supply chain thing. It's amazing. They only applied that first principle, which was the limit suppliers, and they got it down to 1. And after me and Josh went, he went back to him and said, you got to do this, Willis's crazy immutable delivery idea. And they got it down to 0.01. At RSA, this is a production application, by the way. At RSA this year, the gentleman who owns this, we were geeking out like, man, I think you guys are amazing what you've done. This is that going from 10 to 0.01. He says, John, it's 0 now. Like, come on. He's like, Bugfest, pen test, 0. This is a no shit 0. I don't know. I didn't do great in math in high school, but I think that's 1,000 times better. And I already told you the 2,555. So I'm telling you, that there's some. This ain't easy. Not saying it's easy, particularly if you're a large enterprise and you got thousands of different people. Hard as shit. Doable? Yes. Should you do it? If you want to stay in business. Andrew Schaefer, confirmed, says you're either a learning organization or you will be losing to somebody who is. I want to go through quickly with Docker security, what we've done. You saw the scanning. We've got the signed signatures. Again, there are people that talk about Docker the way it was 2 years ago. Oh, Docker's great, but yeah, don't use it in production. Bullshit. I mean, I can tell you, trading, financial trading, billion-dollar latency applications are running in Docker right now. And we've solved a lot of problems. The man in the middle, gone. One of the early things was that when you were in a container, if you got root, you had root to the host. Well, that's gone. We've created that as a namespace. container vulnerability, we do the inspection now. So a lot of that stuff has gone away. I mean, no order, but we've added a shitload of stuff over the last 2 years. Scanning, trusted, which is signed signatures. In fact, we just now do have encrypted TLS network tunnels in our overlay. Read-only containers, names, everything's namespaced. Everything's namespaced now, so now you don't have to worry about anything. We've got all the security supports. If you really want to go nuts, actually, DOD and guys like this, like, we've actually exposed all the syscall. And so if you want to see a really ugly Docker run command, you could literally turn off and on right down to the fine tooth, right down to syscall. It's all there. So you can, like, if you need, like, just this and guarantee nothing else, like, you probably should use Chef or Puppet to build that, but because it's ugly as all get out. Secrets management, here's the thing I love, the thing I talk about, it's called Linux Kit. It's an immutable, it can be built. It was actually from the people, we purchased a company that was unikernel systems. They did all the bleeding edge unikernel systems. They've announced at DockerCon this thing called Linux Kit, which is an immutable operating system that's built from YAML. And the concept now is you literally could, per service, build the complete horizontal berth. And then, so one last thing is, like I told you this, Aetna now kind of drives this model, and I've been helping advise some consulting companies. Like, this is what a DevSecOps looks like. Like, we saw the Jez Humble earlier, blue-green. Like, this is how Aetna gets to this, right? This is the design, their development environment, their CI continuous integration environment. It's all overlaid and automated with all the software delivery. So there should be no difference. A bug is, like what they say is a bug is a bug is a bug is a bug. A security bug is a bug. So we've encapsulated our flow with all the meta, not only of QA and development, but also security. And the last thing, I don't even know why that slide did that, but I think, probably because I stole it from Aetna, but I give attribution. I hate those kind of sliding slides. I just know. I'm sorry if anybody else is going to present with sliding slides, but so one of the things that the guy at Aetna that was at RSA, I was doing they had a DevOps track. I was doing the keynote there, and he was the second speaker, and he came up to me and we geeked out about Docker, and he loved Docker, and he said, "John, I think I got to tell you what we love most about Docker," and it's like this should warm your soul if you like. Otherwise, you'd probably think my presentation sucks. But he said, the thing with Docker is like one service, one container, one immutable or read-only file system, and one port. That one port should just like IP tables, firewalls, one service, one container, one read-only file system, one port. I don't know. I get teary-eyed. That's all I got for you this morning. Thank you very much.